Good evening. It's a bit better. And I guess the first thing to say is welcome back. Thank you all really for joining here tonight. This is the first BTS evening meeting that I have hosted as being chair for the last year and a half in person. So it gives me great pleasure to be here with you all this evening. And we have quite the lineup tonight. It's going to be a really fantastic evening. So first thing to say is we've got a few of the announcements. And for those of you that have been joining me on YouTube, I haven't actually had to do any of these so far. So the first one is to say that I've been told there is no fire alarm planned. So if you hear one, please take note of the emergency exits and use them. The assembly point is located at the corner of Little Great George Street Corner and Parliament Square, Storey's Gate and Prince's Mews. And then lastly, if I could ask you to all put your phones on silent. This is another thing that we haven't had to do when we're at home, watching online. So yeah, and for those of you that are joining us online, please feel free to put comments as well and join us for this evening's event. So, before we start with a number of special things this evening, we actually wanted to take this opportunity to show you a short video. This is a video from Transforming Tunnelling Safety. So if hopefully all of this will work. I've been used to all the transformation of the IT happening for me.
Welcome to this overview of the Transforming Tunnelling Safety Group. Originally formed via interested client organisations who wanted to drive step change in the health, safety and well-being of the tunnelling industry. Safety standards and performance have improved considerably over the decades, but the Transforming Tunnelling Safety Group wants to help deliver a further positive shift in performance. Free access to TTS content and resources is kindly hosted on the British Tunnelling Society's website. And this video provides guidance on accessing the content, the benefits of doing so, and how you can contribute to further improve our web pages.
The Transforming Tunnelling Safety Group provides safety videos, relevant health, safety and wellbeing alerts, good practice guides and proposals, as well as other useful information for the industry. This has all been supplied by previously successful tunnel projects. We really encourage members to use this content with your workforce briefings so that we can all improve health, safety and wellbeing performance. So in addition, we encourage members to submit content based on your experiences, skills and lessons learned in the field. Through this collaborative way of working, we can make the tunnelling industry safer and healthier for everyone that works in it.
Accessing the content via the British Tunnelling Society website couldn't be easier. Simply select the TTS shortcut on the homepage or the red quick links bar. From here you can access a number of resources, including real-life lessons of health, safety and well-being incidents, a range of good practice guides. These have been researched, developed and published by individual organisations or projects. You may find them to be useful references when planning your works. A range of safety videos, contact details for TTS representatives, and our SCATE matrix. The matrix was developed to be used by clients, contractors, and employers to define competence and improve safety and productivity on tunnelling projects. Updated annually with feedback and inputs from the sector, the matrix clarifies the skills, knowledge, attitude, training, and experience required for most occupations within the industry. Videos are an excellent way of engaging the workforce. All our safety video content has been submitted to the Transforming Tunnelling Safety Group by industry-leading organisations. Considerable investment has been made to create impactful videos that cover key risks and outcomes.
The video was very easy to find on the website, and when I played it to the workforce and for everybody in the room, they were really engrossed to it, and you could literally hear a pin drop when we were playing it.
My name's Lawrence Denman. Watched the safety video this morning, thought it had a really good visual impact, and you're going to remember it when you go outside.
We encourage everyone in the tunnelling industry to submit resources to make the website better, and you can do so via the Submit Content to TTS Here link on the homepage. All content is vetted before becoming available for members to use. And for organisations that submit content, the logos will appear in the contributors section of the website. so everyone can see who the leading organisations in the industry are. By industry members submitting content, the website will become even more relevant and beneficial. Thank you for watching this video. As you can see, the Transforming Tunnelling Safety Group is working hard to offer easily accessible, up-to-date, relevant content to improve health, safety and well-being for the entire industry. Don't forget, we really need your contributions too, so please submit any content you can.
Okay, so for those of you that haven't seen that before, please do engage with this initiative and go along to our website to find out more. So that brings me on to one really special occasion we've got this evening. And it is a great delight to be able to present the James Clark Medal 2020 to our recipient tonight, who's been a very patient recipient. So before we do that, I'd like to introduce Mark Leggett and invite him to the stage to say a few words.
Thank you, Kate, and welcome to the BTS in person for the first time as chair. I used to love that job. It was great fun. Before I start talking about Helen, first I'd like to thank you, Kate, for asking me to do this. I know it's a bit odd. We normally do this at the AGM, and it should have been done in 2020, but we live in strange times. First, I'd like to talk a little bit about the James Clark Medal. James Clark worked for Charles Brand and Sons on many well-known tunnels, and he died in his early 60s. And his wife, Madeline, bequeathed a sum of money to provide a medal to be awarded annually to a British tunneller to perpetuate James's memory, and we've done that ever since. And the original criteria were contemporary achievement in tunnelling or innovation, responsibility for a large project. But in the mid-1980s, the medal was not awarded, and with Madeline's approval, a third criteria was added, a major contribution to the tunnelling industry. It is a prestigious award, and it gives us great pleasure every year to award this as the British Tunnelling Society. And I'm really, really pleased that Helen was is last year's recipient in 2020. Helen is a huge figure in the industry, and her experience includes not only very high-profile tunnelling projects, but many prestige property developments, difficult temporary works excavations, and coordination work with city councils and other third parties, such as rail and metro owners. And Helen can work either as an independent advisor or as a member of an established team. And Helen brought the benefits of experience to pre-construction or buildability studies throughout her career, and to packages of active work and complicated work, and she gave impetus and direction to the efforts on site. Helen has significant technical, managerial and commercial experience in the construction of major tunnelling projects. I know you're retired now. At least I think you are. We never quite retire in this industry, I don't think. And Helen has wide experience in groundwater control, dewatering and its effect on structures. And it included the appraisal of settlement and ground movements from tunnelling and the effects on structures and utilities, complex tunnel portals, large diameter TBMs, especially slurry shields and separation plants. And Helen's tunnelling experience, her key projects were Hastings stormwater sewer tunnels, Copenhagen Metro, Jubilee Line extension, and of course the Channel Tunnel, where Helen played a huge role. And I'm so pleased about this because I was very keen that we not only improve the diversity of the James Clark Medal winners, but that it goes to an exceptional candidate, and this in 2020 is no exception. I'm really most pleased about Helen's instrumental achievement in setting up the All-Party Parliamentary Group for Underground Space, which has now become the All-Party Parliamentary Group for Infrastructure. Helen set this up and managed its development over many years, and she kept underground space at the forefront of politicians' minds. And I think it's true to say, Helen, you were a complete driving force in that. It has slipped a bit at the moment, and we would like to get it back to that same level that you were at, but I suspect we might not. But you managed to keep the politicians' attention throughout the events and site visits that you organised. And at the Channel Tunnel, probably your first tunnelling project, was it? was you were responsible for the tunnel construction geotechnical department, and this included all the probing ahead as well as face logging, Natten convergence measurements, amongst other things. And you went on to drive technical excellence throughout other projects. But you have had a major contribution to the tunnelling industry. 30 years with major career with major civil engineering contractors and consultants with significant expertise, which we've had the benefit of for all those 30 years in tunnelling, foundations, deep excavations and basements. But you don't just do tunnelling, do you? I've noticed. And it's really interesting. Almost 20 years ago to the day, there was an article in the New Civil Engineer called The Pleasure of Leisure. I don't know if you remember this. And Helen was quoted as saying, and of course NCE is always, no one from NCE here? Slightly, I'm quoting direct, but the whole of my life is dedicated to working as efficiently as possible so I can clear my desk and do other things. And people without pastimes hang about in the office in the evenings doing nothing. I admire those sentiments, actually. I think it's amazing. And we could all do well to do other things. It said in the same article that you're an accomplished flamenco and ballet dancer and enjoys playing the violin and the harpsichord. And you believed having outside interests made you efficient as well as makes for efficient as well as contented employees. And I believe you. And I looked on Helen's LinkedIn post page, and I saw your marvellous lino cut prints, the exhibitions, participating in the exhibitions that you've done in 2018, 2020 and 21, and the It's an Ill Wind book cover, an anthology of writing by Canterbury Public Library, Wise Words of Wellbeing Writing Group, writing from the first lockdown March to July 2020, published by Helen Nattrass. I haven't read it, but it would be amazing too. And of course, you've been the musical director and secretary of the Canterbury Gregorian Music Society since 2007. So, for me, Helen, hugely talented tunnelling engineer, made a significant and massive contribution to the British Tunnelling Society and a very worthy recipient of last year's 2020 James Clark Medal. I believe you would like to say a few words afterwards. Thank you.
Take the stage back.
Well, ladies and gentlemen, this is a big surprise. I did not expect this award. If you could imagine me 18 months ago, I'm sitting at my desk at home, and this email comes on, it says, James Clark Medal. I thought, what on earth's that? I'm not on this committee anymore. Which idiot has sent that? And I was about to delete it. And I thought, I wonder who it is this year then. So I sort of opened it up and it said, Helen Nattrass, we are delighted to... I thought, what? This is a hoax. So I phone up Ivor Thomas and say, what is this? Do you know someone's hacked your email? And sent me this ridiculous message. And he goes, it's true. Oh, speechless. So I sort of sat down and I thought, well, why have they awarded it to me? What have I done? I thought, I've had 40 years of writing reports about things like asset monitoring that shows absolutely nothing, and writing a report about it every week, which nobody ever reads. That sort of thing. And then I thought, well, could it be for playing the piano for the sing-song at a breakthrough parties, things like that? No, maybe not that. And then as somebody else has kindly said, could it be for inappropriate displays of whatever dancing is flavour of the month at the said parties? No. Well, I actually came to the conclusion that really my major contribution to this learned society is, as Mark has said, the foundation helping to found and run the all-party parliamentary group. Because with a group like that, we have the opportunity to show our skills and our knowledge in its breadth, depth and variety to the people who govern this country. And we don't actually blow our trumpets enough about that. And I soon learnt, mixing with politicians, that it's not enough to give them an interesting presentation. What they want to know is, what do you want us to do? That is the question they ask. What do you want us to do? Well, by taking them on visits to tunnelling construction sites, by organising talks in the Houses of Parliament over the road, I showed them what we want them to do. And also people from the client sector, the designers, constructors, the men at the face, they all had an opportunity to tell the people who govern this country what we want them to do. And of course, there are times when you have amusing things that happen. Very early on in my organising these things, I took a group of parliamentarians down the Northern Interceptor sewer, that wonderful testament to Victorian engineering, Basil Jet. Well, you can imagine the people over the road there. They're used to walking around in nice corridors, carpeted in green or red, as the case may be. And they come to a tunnelling construction site, and the first thing they do is they get the induction talk, and they get told about the self-rescuer. Well, first of all, that strikes the fear of God in them, the fact that they could be gassed down a tunnel. One peer quoted as saying, "Oh, what a way to go." Then they get the harness on, and they're lowered down from the tripod into a sewer, and they have to walk about in it. One peer of the realm said, "Oh, I say, I've got lavatory paper around my Wellington." One of the lads goes, "Turn round, sir, it'll float off with the stream." "Oh, wait till I tell them about that in the tea room." One other notable occasion when I had a group of parliamentarians turn up, and there's never that many, but some very unusual people. And in one group I had the Astronomer Royal, the former president of the Royal College of Physicians, and a former president of the Royal Society, all going down a tunnel not far from Stratford. So they were all there, and it's all an opportunity for us to influence the policy that goes into infrastructure that makes jobs for us and the people we employ. And I like to think that's a big door that I've opened for all the people in this society. And on a personal note, one of the achievements I'm proudest of for myself was organising a symposium in honour of the late Sir Alan Muir-Wood. Sir Alan was a great figurehead for me throughout his career, and albeit at a distance, was a kind mentor. And I was pleased to be able to remember him in a fitting way by organising a symposium in this room. So in conclusion, ladies and gentlemen, I'm honoured to receive the James Clerk Medal. The approbation of one's peers is an accolade beyond value. Thank you.
I think you can all agree with me that that is a very well-deserved award. Thank you. So I'd like now for tonight to invite our two guest speakers to come up to the stage. They've been hiding in the corner here for a little while. So, Tonight's lecture is on low, intermediate and high pressure compressed air work, and it's the launch of the revised BTS CAWG guide. And tonight's speakers, we have Dr. Donald Lamont and Roy Slocombe. So Donald's first exposure to compressed air was as a resident engineer on the construction of 2 small hand-dug tunnels driven under compressed air at Dalry in Ayrshire in 1980-81. On a good day, pressure peaked at about half a bar. This experience helped Donald to get a job with the HSE in 1984 and in 1987 to become HSE's National Specialist in Tunnelling and Compressed Air Work, a post he retained until semi-retirement in 2010. During his time with HSE, Donald drafted the engineering part of the 1996 Regulations and Guidance Document L96 and had the foresight to ensure that high-pressure exposures could one day be undertaken without a change in the regulations being required. He was behind the implementation of oxygen decompression in 2001. He championed the use of mathematical modelling of decompression profiles along with post-decompression Doppler monitoring. Donald inspected almost all compressed air tunnels built in Britain and Northern Ireland during his time in HSE. And in the early 1990s, he also had the responsibility in HSE for inshore and inland diving. He commissioned research into fire in compressed air and heat strain indices in hyperbaric environments, as well as obtaining a PhD from Aston University for a study of decompression illness in the UK from 1984 onwards. In 2010, Donald set up his own consultancy, Hyperbaric and Tunnel Safety Limited. He has been associated in some capacity with 6 high-pressure compressed air projects since then, from Hong Kong to Vancouver via Suez, the UK and Ireland. The most rewarding engagement was as the independent hyperbaric advisor to the client for the Tuen Mun tunnel project in Hong Kong, where pressures reached 6 bar in trimix saturation. As an amateur of the ITA Working Group 5, he has completed 3 editions of the ITA BTS Report 10 on high-pressure exposures. He is currently leading the revision of EN 12110 airlock safety in Europe. He is a long-standing member of CAWG and was the principal author of the 2021 guidance. Our second speaker, Roy Slocombe, has been involved with tunnelling and mining throughout his career, and his experience of compressed air began in the early 1970s when he worked on a series of hand-excavated drainage tunnels. When at Specialist Plant, he and Peter Remnant developed innovative airlock systems using steel bulkheads that could be quickly installed, especially if needed when the tunnel or tunnelling machine encountered difficult ground conditions. One of the most unusual applications of compressed air was when they were called upon to pressurise 2 huge concrete structures that were being towed out into the North Sea from a Norwegian fjord where they have been constructed. Having been involved with the Compressed Air Working Group since the 1990s, he has supported Donald in the preparation of the guidance. And I'm very pleased that we've got both of you here this evening.
I'm sure you'll be pleased that my CV was kept purposely short so you can get to the bar a bit quicker. But as Kate said, it's very nice to be here, back at Great George Street. For me, the one thing I didn't mention in my CV, I think it was this meeting 50 years ago was the first time I attended Tunnelling Society. In those days, it wasn't the numbers that we've had in more recent years, but probably on a par with tonight. And I can remember sitting 2/3 of the way back there, thinking I was by far the youngest guy here, very conscious of the fact I was the only guy who'd been underground in compressed air. I was setting out in a hand-dug 5'6" in Southsea at the time. I remember sitting there checking my hair used to be a lot longer in those days, whether there was still a bit of mud left in behind my ear. Presentation tonight, split tonight, I'm just the warm-up act. A very quick comment on some of the changes in the latest revision of the guidance, and particularly I know Donald will then speak quite a lot more, because one of the biggest changes is the recognition on the expectation of work above 3.5 bar, which previously that had been the statutory limit in UK. Don will explain why, but it's because that was the maximum. It was seen you could safely decompress on air. But now with the improved practices that have been introduced, it'll be quite different. So Donald will talk more on that, so I'll just run up to it. Along the compressed air working group, we're quite lucky. We've got quite a range of people involved, broad range of experience and expertise that's brought together and enables us to put these things together. The compressed air working group was originally formed by the Medical Research Council in response to the decompression illness problems that were occurring on some of the big tunnel projects at the time, like the Clyde Tunnel, Tyne Tunnels, Blackwall and the like. That led, in 1973, Syria produced their Report 44, which was a big step forward at the time about the medical code of practice for working compressed air. That introduced the Black Book tables, which although we may now, by today's standards, think could be improved, at the time they were a big step forward. And Val Hempelman, who developed those tables, was always very proud of the fact that since the introduction of the Blackpool tables, there had not been a fatality due to decompression illness in the UK. As time went on, the aims of the Medical Research Council changed, and in the early 1990s, the Compressed Air Working Group became a subcommittee of the BTS. That led on then, and cooperation with HSE, to the publication of the 1996 Working Compressed Air Regulations. And then later, when they were changing government policy that led to HSE, instead of writing prescriptive guidance, they were producing more goal setting or target setting documents that were more guidance, and relying more on industry guidance. And whereas some aspects of the industry, they had very much a trade organisation capable of taking it on, with compressed air, it was felt that that was something that the BTS could push, or could think. Okay, so we've looked at some of the changes, because since the original compressed air regulations, the whole nature of compressed air work in the UK and to an extent worldwide has changed. Because in the past it was common that the whole tunnel would be compressed, and excavation was either by gangs of miners by hand at the face with open face, or sometimes using tunnelling machines, but always operating wholly within the compressed air pressurised workings. But whereas now, with the changes that have taken place, it's now exclusively used for short excursions, either face inspection or TBM maintenance. The developments in machine technology over the years have also allowed tunnels to be done deeper with much higher pressures. This in turn meant that you're then looking at much higher working pressures for face access, and that's led to the introduction of higher pressure working techniques that have been developed for the offshore diving industry. And this has included the use of non-air breathing or mixed gas mixtures rather than just natural air. And that hasn't much done as yet in the UK, but it has been done quite extensively overseas. That's also led to this clarification of definitions, because low pressure areas still work at low pressures that don't need a stage decompression. So with current guidance, that's below 0.7 bar gauge. All the pressures we talk about are gauge pressures, because we're all sat here at 1 bar absolute now. I think Donald mentions this later, but we always talk about gauge pressures, so just pressures above atmospheric. Intermediate pressure is a definition that's now introduced, because that's then work above 0.7 bar that needs a stage decompression, but is still below the 3.5 bar limit, which was the statutory limit. It's still a statutory limit in UK, but it's recognised that by applying for exemption, this will be forthcoming to allow work at higher pressures. The latest version of the guidance now includes quite extensive guidance on work at pressures above 3.5 bar, which is something Donald will comment much more on. And includes changes, because over the years as well, there have been a number of changes within the European standards and with British standards, which are referred to in the document or interface with the document. The guidance is primarily drafted, for use in the UK. We are the BTS, but we know that it's often used elsewhere in the world, especially where there isn't or there's a lack of local regulation. And I know that's something that members of the group can be justifiably proud of, that the experience that they bring to the guidance is recognised overseas. Other relevant documents, this is ones that mesh together. 6164, health and safety in tunnelling, that's very relevant. The next two, mainly European standards, or the BS harmonisation thereof. 16191 is a lot of the machinery requirements, more on the shields and the rest of the equipment. 12110 is specifically airlock safety requirements, mainly aimed at airlocks, which are an integral part of the structure of the TBM, but most of the guidance can still be applied in other situations. The ITA Report 10, that was jointly written with Compressed Air Working Group, again with a big input from Donald, who was the animateur on that working party. And as a consequence of that, I'll come to that. HSE, probably going to mention the doctors again later, and yes, the last one, the ITA Client's Guide to High Pressure Work. That was prepared a couple of years ago because it was recognised that whereas most of the responsibility, if not all the responsibility, for actually using compressed air will fall to the tunnelling contractor, often it's good that the client at an early stage can anticipate the use of compressed air, and more importantly, not do anything that will then cause a problem later. 12110 is being revised at the moment. Several of the changes that are incorporated into the compressed air guidance also will be incorporated into 12110. Once 12110 is published, or the new revision, that will take precedence, but for the time being there's some interim guidance included. As we say, that's ITA Report 10. We were very pleased that they acknowledged the input from Compressed Air Working Group with the addition of the BTS logo on the front cover. We always think it's good. It helps to raise the international profile of the Tunnelling Society, which we think is quite good. Compressed air contractor. It's recognised throughout that the compressed air is a bit like principal contractor of the CDM, has the major role in pulling everything together, has the general responsibility for the work in compressed air. Yes, he consults, or they consult with the relevant specialists, which again is set out in the document how this guidance works in to help him with his decisions. The one change that has happened over the years is that a few years back they actually withdrew the requirement to use approved procedures. In previous their guidance, the 96 regulations, there were tables set out, and in fact if you wanted to use a different decompression table you had to apply for an exemption. Even if you wanted to use a table which everyone was in agreement was more conservative and therefore better, you still had to apply for an exemption. But they no longer want to approve procedures, and therefore it's left to the compressed air contractor in conjunction with his specialist to select appropriate procedures for decompression as part of the safe segment of the work. The HSE retained the requirement for an exemption for work above 3.5 bar, and that's the recognition there's a lot more preparation, a lot more consideration has to be given for this. And the other thing that I mentioned there, again Donald might mention, is that under the current status is that if there's a perceived benefit for using mixed gas below 3.5 bar, then that's possible. Quite a number of changes with the plant and equipment, and again, as I mentioned, that although it's generally talking about airlocks on a tunnelling machine, the requirements about furnishing the locks and the equipment are quite as applicable if it is a tunnel lock or a boiler lock on a bulkhead. The one thing that we did come look at for consideration is the prospect of having a sufficient storage of compressed air, so no matter what mayhem happens back out in the tunnel, you can still safely decompress the people, and if it is a fire, anything out by, you can then decompress them safely and get them into the refuge. Because at the end of it, all the guidance and requirement is aimed at safe working and looking after the safety of the guys that are working in compressed air. The intermediate chamber, on a lot of big machines it's already there, but this is emphasising the requirement so that there's somewhere between the working chamber or the excavation chamber of the machine and the airlocks, so where mixed gas is being used, there's another place where that's fed through to the working chamber, and that the guys have a dirty working area to change into clean overalls before going into the airlock, especially if it's a lengthy decompression. Oxygen is another thing that was clarified. It had always been accepted, and always in risk assessments or method statements, you'd say that if someone suffers from a severe decompression illness immediately on coming out of the airlock, that the practice would be to recompress them. We're clarifying here the requirement that will also be in 12110, that therefore to accommodate that, the whole system should be capable of working at 1.8 bar gauge, and that's to allow a US Navy Table 6 therapeutic decompression, which is the sort of seems to be a worldwide standard for therapeutic recompressions. Surface habitat, Donald might mention a bit more on that, is this is very new because this only comes in if we are looking at the saturation diving techniques, so that people are living under pressure in a surface habitat for 14 or 28 days and then making excursions under pressure to do the maintenance rather than compressing and then decompressing after every visit. It's seen as quite beneficial as far as the working times that are possible, but also from the health and safety of the people. They are only having one very slow decompression instead of a decompression after every visit. So when we talk about much higher pressures, then this is a benefit to all concerned. And at the moment there isn't a standard, either a British or European standard for habitats. This is likely to be forthcoming, but in the meantime the requirements are in EN 12110 or BS 12110, and this guidance do follow, good guidance to be followed. Similarly, the transfer under pressure shuttles, that's something that only comes in if you're using saturation techniques. This is effectively a mobile pressure chamber that transfers the workers from the surface habitat to the working chamber on the shield. And again, there will be requirements in 16191 to have a clear path through the backup. It's very important that where this chamber is taken in, lifted up into position and travels through the backup, you need a good clear route through the other equipment on the backup, so there's no impedance to the safe transfer. Contract medical advisor, there's several changes in the document about the contract medical advisor. As it says, he's the guy who's responsible to the compressed air contractor for aspects of occupational health. There are two different roles, but very often they are covered by the same person, which is good because for continuity. But the contract medical advisor and the appointed doctor aren't necessarily the same, but it's better and unusual that they are. once we're into the situation where we're not relying on HSE to either specify or to approve tables, then a lot more thought has to go on, and particularly if we're looking at new tables. Obviously, where you're using tables with an extensive and proven history, that's one thing. If it's a new table, a lot of work can be done theoretically. There's a lot of work done theoretically to look at the degassing of the people. Again, Donald will mention more on that. But where it is new tables, then they have to be assessed. In the past, we say the incident DCI is not a reliable measure. In the past, when we were talking about big gangs of men working in handwork, there were a lot of statistics coming out, and therefore the work that was done by the Newcastle Registry, the Group Secretary Tony Evans did a lot of work on this previously. That was an indication of the effectiveness and the safeness of decompression tables. But now better techniques are coming available, and the use of Doppler monitoring, which is a way of checking up any bubbles in the bloodstream, either during or post decompression, is a very effective way. And that can demonstrate if you aren't getting bubbles, then it means that basically that the decompression table has been successful. You've been able to get the excess gas out of the tissues and not leaving any to go bubbling about, and that's what can cause the problems. It's recognisable that other techniques may become available, because the Doppler technique's now been around for a few years. If anything else does come, then obviously there's scope to use that within this guidance. The medical surveillance, as we say, that's still where the appointed doctor and contract medical advisor are quite important. The ongoing medical surveillance, yes, and maybe the most important is the assessment of people's fitness for working compressed air before they actually go in. And particularly as we go to higher pressures, that becomes more and more important. Okay, at which point I'll hand you over to the main act, and he'll tell you a lot more interesting things.
Thank you, Roy. Good evening, ladies and gentlemen. Tonight, I don't want to spend time going through the content of the revised guidance or Report 10. You can read that for yourselves. I want to address three issues: the phenomenon of saturation, the technical differences between working compressed air and diving operations, because people refer to what we do in compressed air as diving, and it's not diving, and I want to explain the differences. And I want to explain also why 3.5 bar, from a physiological point of view, is a good pressure to move to mixed gas. So we'll start off with saturation. Saturation is a natural phenomenon. How many people in the room think they've experienced saturation? One or two, fine, thank you. We'll see how many put their hands up later. This is a slide I've used many, many times to explain the theoretical background to compressed air work. It's very simple, really. You have the ground level, the green line. You have the water table, which is the blue, and you have a tunnel, which is the black, and somewhere in the tunnel you have a bulkhead, which separates the tunnel face from the rest of the tunnel, and that bulkhead is pressure tight. The water pressure distribution in the ground is triangular. The deeper you go, the higher the pressure. You apply compressed air to the tunnel. Air is of virtually no density. As far as we're concerned, in tunneling anyway, it's no density. Therefore, the pressure distribution of air is rectangular. And you'll notice that there's one point where the air pressure and the water pressure are equal. You can vary the air pressure to vary the balance point, but you have a balance point, and above the balance point, air pressure is greater than water pressure. Below the balance point, water pressure is greater than air pressure. And that's a bit of a nuisance, as far as the geotechnical engineers and the civil engineers are concerned. And just for reference, 10 metres of water is roughly 1 bar of air pressure. Right. Roy mentioned gauge pressure. Normally in compressed air work, low and intermediate pressure, we tend not to even mention gauge, we just talk about pressure. We assume everybody realises it's gauge pressure. However, there is another pressure which is important, and the higher the pressure you're working at, the more important it becomes. Absolute pressure is what you have to start to appreciate. And absolute pressure is gauge pressure plus 1 atmosphere. And many of the gas laws that apply to high pressure compressed air work depend not on gauge pressure, but on absolute pressure. So it becomes quite important when you're stating a pressure to note if it's gauge or absolute. The other pressure that's important is partial pressure. And if you go back to your school science days, you may remember what partial pressure is. If not, I can remind you. It's the absolute pressure of an individual gas in a mixture of gases. The partial pressure is the volume fraction of a particular gas times the absolute pressure in bar. For convenience sake, we are all in air here at the moment, and air is roughly 20% oxygen and 80% nitrogen. So as far as we're concerned here today, the partial pressure of nitrogen we're experiencing is 0.8 bar, and the partial pressure of oxygen is 0.2 bar. Now, the engineers who are here tonight are very aware of confined space work, and 20% by volume is this oxygen figure you want to avoid problems with low oxygen and confined space work. In actual fact, it's not 20% by volume it's important to living, it's 0.2 bar. It's 0.2 bar pressure of oxygen which sustains life. So not the 20%. 20% is the easy way to measure it, it's a 0.2 bar that's important. Coming to saturation. Saturation is a natural state of dynamical equilibrium in which the partial pressure of the gases in the body tissues equal those that are being breathed. It's nothing to do with diving, it's not exclusive to compressed air, it's a natural physiological state. And I say dynamic equilibrium because all the time oxygen is going into the body and being metabolized, nitrogen is going in and coming out as we sit here. So it's a dynamic equilibrium, but at the moment where we are in this room, we're experiencing the 0.2 bar oxygen, the 0.8 bar of nitrogen, partial pressure. If you increase the pressure, you introduce a state of partial saturation until saturation is re-established. If you reduce the pressure, you have supersaturation until saturation is re-established. But nature always wants the body to be in a state of saturation. And saturation takes between half an hour and an hour to re-establish for the sort of vital organs in the body. It can take 12 to 18 hours to re-establish for tissue that's slow and diffusing, like the legs, the muscle, the fat, the bone, and so on. Once you're saturated, no more inert gas will pass into the body if you don't change the pressure or the concentration of the gases you breathe. So what I can say, total certainty, is we are all saturated in this room with oxygen at 0.2 bar and nitrogen at 0.8 bar. So we have all experienced saturation. Life is one long saturation exposure in air. Saturation is nothing to be frightened of. We are all perfectly happy, and not one of us here is a diver at the moment. So saturation has nothing to do with diving. It's a technique used in diving, but it's not only in diving. There are two types of exposures in compressed air work. You have non-saturation exposures, which are short, single exposures during a shift. The compression, the working period, and the decompression all take place within a single working shift. And part of the body might be saturated, but part of the body will not be saturated because of the short duration of the exposure. In high-pressure non-saturation work, the compressed air workers breathe mixed gas by a mask from compression through the working period till partway through the decompression, when the mask can be taken off and it's safe to breathe air again. And non-saturation exposures are limited around about a pressure of 6 bar, equivalent to 60 metres of water depth. Because of the need for decompression, your exposure is relatively short, and the productive work is probably somewhere between 3/4 of an hour, maybe up to an hour and a half, depending on the pressure you're working at. And you have one decompression per exposure. On the other hand, a saturation exposure is a very different thing. You have a compression phase, you have a long period under pressure, and that can be 14, 21, up to about 24 days under pressure constantly. And then you have a long, slow decompression at the end of that, back to atmospheric pressure. And a decompression can be 2, 3, 4, 5 days to undergo. The people undertaking high pressure saturation exposures breathe the mixed gas by a mask when they're in the excavation chamber and the intermediate chamber, because they are air pressurized. But when you're in the habitat or the transfer shuttle, then they are gas pressurized and a mask is not required. Again, repeat, once you're saturated, no further gas is taken on unless the pressure is changed or the breathing gas mixture is changed. And in saturation exposures, each day the productive work is somewhere around about 4 to 6 hours, depending on the conditions. So you can see the productive work is much greater in saturation work. And also you've only one decompression every 28 days, and decompression is the high-risk activity. So saturation work is inherently more productive, probably safer, but a lot more expensive, I have to concede. That's what I want to say about saturation. Just remember, we are all experiencing saturation. The second thing I want to talk about are some of the differences between compressed air work and diving. Now, it is possible, although it's very seldom done, to put a diver into the head of a tunnel boring machine to change the cutter tools. I'm not talking about the practicalities tonight of putting a diver in compared to putting a fitter or a miner in to change the cutter tools. I want to talk about the hyperbaric differences between the two types of activity. First is to look at buoyancy and orientation. A compressed air worker works more or less vertically, standing up, and is not buoyant because they're immersed in air. Therefore, they do considerable physical work in the course of a shift working the cutter head. The lower limbs in particular are working hard to support the weight, working and so on, and this can cause fatigue in the worker. It also affects gas uptake and blood flow. On the other hand, a diver is roughly horizontal in the water and they are buoyant. Therefore, the lower limbs are not working to the same extent as a compressed air worker. And blood drains away from the lower limbs into the upper part of the torso. So the distribution of blood in the body is quite different. And somewhere between half a litre and a litre of blood will move from the legs into the chest and abdominal cavity if a diver is working horizontally compared to a compressed air worker working vertically. Now, these changes can affect decompression, so don't assume that diving tables for decompression can be used for compressed air tunnelling. They might be able to be used, but there are differences, orientation, buoyancy, and so on, which can make a difference to their effectiveness. The second thing that's different between a diver and a compressed air worker is the environment they're immersed in. A diver is normally immersed in water, and a commercial diver in the North Sea will wear a hot water suit, which keeps them warm. Other divers will wear dry suits, and the dry suits are inflated using the same gas as the diver is breathing. So there's no difference in gas between outside the body and inside the body. On the other hand, a compressed air worker can either be immersed in air or in gas, depending whereabouts they are. If they're in the habitat, they're breathing gas, they're immersed in gas. If they're in the shuttle, they're breathing gas, they're immersed in gas. They go into the tunnel lock, they breathe gas, they're immersed in gas. They pass into the intermediate chamber, and right away they're immersed in air. They're still breathing gas, they're immersed in air. Into the cutter head, immersed in air, breathing gas. Now, helium is part of the normal gas mixture, and helium's a light gas and a mobile gas. And helium can diffuse both through the tissues by inhalation, it can also diffuse through the skin. So you find that in the situation with tunnel workers, they are working in air, they are breathing gas. So they have a lot of helium in their body, but they're also immersed in air, which is nitrogen. They then go into a gas atmosphere, and immediately helium will try to diffuse into their bodies, and the nitrogen in the bodies will diffuse to some extent out through the skin. Now, because the helium is a more mobile gas than the nitrogen, the diffusion inwards can exceed the diffusion outwards, and you can end up with supersaturation. No change in pressure, you can end up at an element of supersaturation. That again can cause problems because we know supersaturation generates bubbles, and bubbles can generate a skin bend in extreme circumstances. So again, there's a difference there between a diver and a compressed air worker. There are some very significant operational differences between working in compressed air and working as a diver in a similar environment. I say I'm not talking about the practicalities, I'm talking about the hyperbaric differences between changing tools in a cutter head by diving or by compressed air work. In compressed air work, the supervisor, whoever that may be on the surface, controls the pressure in the excavation chamber to ensure face stability, to control water ingress, and to prevent blowout. The problem of the imbalance between a rectangular distribution of pressure for air and triangular distribution of water pressure. The supervisor also has to monitor the airflow to make sure that the airflow into the ground is not excessive. In low and intermediate pressure work, the people working in the working chamber merely breathe the air atmosphere. For high pressure work, however, they're breathing mixed gas, and the supervisor has to control the flow of mixed gas through the umbilicals. Whether you call them compressed air workers, hyperbaric air workers, mixed gas workers, or mixed gas saturation workers, doesn't matter, just don't call them divers. And that gas supply is normally around about 7 bar above ambient pressure. On the other hand, in diving, the diving supervisor does not control the pressure. The pressure is a function of depth. You're in water, you're surrounded by water, pressure is purely a function of depth. The supervisor merely monitors the pressure. Again, the supervisor does control the flow of gas. So you can see there's an operational difference between what the supervisor has to do in diving compared to tunnelling. There are two types of work in the cutter head. We can either call them an intervention. An intervention is a period of work in the cutter head in the excavation chamber at the same pressure as the habitat. Habitat pressure is storage pressure. So then you go into the shuttle, into the airlock, into the cutter head, but you're working at the same pressure the whole way through that operation. And Val Fluke, some of you know Val Fluke from her work in compressed air and mathematical modelling, she likened it to being the same as a free air intervention, but at an increased ambient pressure. So an intervention, there's no difference in pressure between the pressure you're working at, the pressure you're stored at. On the other hand, an excursion is a period of work in the excavation chamber at a different pressure to storage pressure. And normally it's a higher pressure. To go to a lower pressure can introduce some problems with a slightly higher risk of bubbles and decompression. But normally an excursion is a higher pressure than storage pressure. And if you think of that as a no-stage decompression exposure, but at a higher ambient pressure, that's the nearest analogy that is there. There are limits on excursion pressure, and I've taken this table from the Norwegian offshore diving standard, and you can see that the limits on excursions are actually quite tight. If you're storing at between 3 and 4 bar gauge, then your maximum pressure increase or decrease is only 0.7 bar. If you're 4 to 5 bar, you can go to a pressure difference of 0.8 and so on. Now, high pressure compressed air work has typically been used on large tunnel machines for road crossings under estuaries, where you're talking about 50 metre diameter cutter heads. You actually have to be at a pressure of 18 bar, 180 metres depth of water, before the excursion allows you to go 15 metres or 1.5 bar from storage pressure. And just to illustrate that, there's the air pressure distribution. This is where the air pressure distributions come to our aid. The left-hand picture, the air pressure distribution is rectangular, and therefore once you're in the cutter head, the same pressure applies throughout the cutter head. So you can carry out work in the cutter head as an intervention. You can service the whole of that cutter head at a constant pressure, no matter what depth you're at. So all parts of the excavation chamber are accessible as an intervention. On the other hand, if the cutter head was filled with liquid and you put a diver in, you'd have that pressure distribution that's shown in blue. The pressure would increase with depth, and the most the diver could do was the excursion limit from storage. If you're at 4 bar and your limit is 0.7 bar, then you can only service half that cutter head, not the whole cutter head. So the difference in pressure distributions makes a fundamental difference between working compressed air and diving. And this really is, I think, the most important difference we should be aware of between diving and working compressed air, and why when people talk about going into a cutter head with divers, they don't actually understand what they're talking about. The third thing I wanted to address was why mixed gas at over 3.5 bar gauge. You hear people say, oh, we can go to 5 bar, 6 bar, 7 bar. Yes, but can you do it safely? That's a different matter. There are 3 gases of interest in breathing mixtures. There's oxygen, there's nitrogen, and there's helium. Looking at oxygen. Oxygen is essential for life. You must have 0.2 bar partial pressure to live. However, too much oxygen is bad for you, very bad for you. So you always need to prevent hypoxia, lack of oxygen, so your partial pressure of oxygen in any breathing mixture must always be 0.2 bar or more. It's quite good practice to allow for a sudden loss of pressure due to a burst pipe, a blowout from the cutter head and so on. So it's good practice to work with a partial pressure of oxygen around about 0.4 bar in storage. It gives you a safety factor against something like a pipe or a hose bursting. So a normal storage pressure would be around about 0.4 bar, twice the normal pressure we have at the moment. It's also good practice to increase the partial pressure of oxygen during the working period. Giving the workers a bit more oxygen, it makes them work a bit more effectively, and it reduces some of the stress on them from breathing. And a partial pressure of oxygen during work of around about 0.6 to 0.8 bar is considered to be acceptable. However, you do need to prevent both acute oxygen toxicity, which is neurological in manifestation, and chronic oxygen toxicity, which is pulmonary in manifestation, and therefore there are upper limits on oxygen as well as lower limits. Looking first at acute oxygen toxicity. It's the central nervous system that's affected. The symptoms are facial twitching, convulsions, muscle spasms. You get no warning, and there are no tests for susceptibility. And there's significant difference between individuals and between the same individual on different occasions. Particularly in diving, oxygen toxicity resulting in a convulsion or nausea very often means the diver, particularly a scuba diver, will spit out the mouthpiece. Once they've spat out the mouthpiece, they effectively are going to drown. So oxygen toxicity is a very serious issue in diving. In tunnelling, a little bit, still important, but perhaps a little bit less critical than it is in diving. The upper limit on partial pressure of oxygen for non-saturation or saturation exposures is 1.4 bar. It's a conservative limit, but it derives really from the diving industry, where the consequences of oxygen toxicity are very often fatal. So the upper limit is 1.4 bar. Roy talked about decompression illness. If you go for treatment decompression illness, you get oxygen at 1.8 bar gauge, which is 2.8 bar absolute. It's 100% pure oxygen, therefore the partial pressure you breathe is 2.8 bar. Yes, you're on the risk of oxygen toxicity, an oxygen toxicity problem, but in treatment of decompression illness, you're in a chamber, there's an attendant with you, you're in a controlled environment, therefore the risk is still there, but is much less likely to be serious in consequence. And if you do have an oxygen toxicity problem during treatment, then immediately put the patient on air, and that removes the problem. So that's acute oxygen toxicity. There's also chronic oxygen toxicity due to long-term cumulative exposure. And the symptoms are tracheitis, inflammation of the throat, the windpipe, and loss of lung vital capacity. Your lungs effectively reduce their effectiveness and reduce their working. Because they don't need to work so hard, you're breathing a lot of oxygen. So again, there are limits set on long-term oxygen exposure. The limits are set in terms of OTUs, oxygen tolerance units. They used to be called units of pulmonary toxicity dose, but people didn't like the word toxicity, so they stopped calling them UPTDs. However, it's actually quite important to recognise that the limits that are set are based on pulmonary symptoms and not on neurological symptoms. I did an expert witness job fairly recently where somebody was claiming for neurological damage because they'd been exposed to too high levels of oxygen long term. And they were saying that they'd breached the limits on oxygen tolerance units. But that limit is not on neurological, it's on pulmonary. So the limit doesn't necessarily apply to pulmonary to neurological symptoms. The sort of limits that you would apply on a daily basis are around about 300 to 400 OTUs per day and around about 1800 to 2100 per week. And you will see that if you work it out, 7 days at 300 breach is at the very top end of the weekly limit. So the longer you're exposed, the more the limits come down. And again, going from a high oxygen mix to a lower oxygen mix is the treatment. Oxygen toxicity is not a problem below a partial pressure of half a bar. At 1 bar partial pressure, you accumulate 1 unit per minute. So if you're in pure oxygen, you're accumulating OTUs at the rate of 1 per minute. If you go to 5 bar on air, and people see no reason why you can't, you're accumulating 80 OTUs per hour. 4 hours at 5 bar, and you're up to your daily dose. Likewise, I've talked about in saturation work, a working partial pressure of 0.7 bar. 10 hours at 0.7 bar gives you around about 280 units per day, which is about 1900, 2000 per week. So you can just get away with a partial pressure of 0.7 bar for a weekly dose. The next gas which causes problems is nitrogen. Exposure to high pressure nitrogen gives you 3 different risks: nitrogen narcosis, increased work of breathing, and decompression illness. And that's measuring it by Doppler score rather than by number of DCI events. In actual fact, nitrogen is the determining factor in deciding when to abandon air as the breathing medium. Narcosis is a primary risk. The work of breathing closely follows a secondary risk. Decompression is not a particular problem. You can design tables to take you back from 7 bar in air, but you shouldn't be there in the first place. Nitrogen narcosis is one of the primary problems of high partial pressure of nitrogen. The symptoms: confusion, disorientation, eventual loss of consciousness, and death. Some people claim that you can acclimatise to high partial pressures of nitrogen, but then some people who drink 2 bottles of vodka a day claim that they're not drunk and they can acclimatise to that. You don't actually acclimatise, you develop coping strategies. Really. You can do little bits of behavioural things, but you're either under narcosis or you're not. If you drink alcohol, you're either drunk or you're not. There's no getting away from it. You don't really acclimatise. So in terms of what's a safe level, we need to consider the symptoms. The other thing is, these days, how many sites have a drug and alcohol policy? How many sites have a zero tolerance drug and alcohol policy? Yet, we're quite happy to put people into high pressure nitrogen to cause narcosis. There are the symptoms. Below 1 bar, no symptoms noticeable. 1 to 3 bar, performance slightly impaired, slight euphoria, and you work up to 7 to 9 bar, mental confusion, hallucinations, and over 9 bar, you're probably incapacitated, unconscious, and dead. I read a Navy report just last week, and it was talking about the research into nitrogen narcosis of the helium as a substitute. The diver went to 60 metres to complete the task, was unable to do so, and returned to the surface. The next day, the diver went to 60 metres on helium, completed the task, and returned to the surface. So the difference of the 2 gases is quite significant at that pressure. This chart on the left is a graph that compares nitrogen narcosis in terms of, on the y-axis, pressure with level of incapacitation going by along the bottom axis in terms of glasses of wine, pints of beer, and so on. We recommend in the compressed air working group that 3.5 bar is the limit that should be used on air for because of nitrogen narcosis. We would be quite happy if people switched to mixed gas at around 3 bar. The red lines on the graph join up the blood alcohol level of the legal drink driving limit in the UK with pressure. And if you're on the legal drink driving limit, then you're about approximately the same as 3 bar air pressure in nitrogen. The blue lines are the UK limit for diving. You can go to 50 metres in air in diving, and that's equivalent to about 4 pints of beer in 30 minutes. And again, I say, what's your company's drug and alcohol policy? Zero tolerance. We then move to helium. It's an expensive, low-density, non-narcotic inert gas with a high thermal conductivity. It's used to dilute the nitrogen and the oxygen and keep the partial pressure of both gases within the required limits. Helium, because it's a low-density gas, makes breathing easier, and hence there's less carbon dioxide retention. There's a problem in high pressure. Above around 15 bar, helium can result in high pressure nervous syndrome, which is a bit of a shake or tremor. But it can be, again, that problem doesn't really occur in tunnelling, so at the moment we don't go to these sort of pressures. Because of the cost of helium, you tend to want to start looking at helium reclaim, where you reclaim the helium from the exhaled gas. Helium is a commodity traded on commodity markets. At the moment, it costs about £35 per cubic metre at atmospheric pressure. Well, you breathe 40 litres a minute, so about every 20 minutes or so, you're breathing 35 pounds worth of helium if you're doing it at atmospheric pressure. The fourth gas I want to talk about, and that slide before was deliberate, when I talked about 3 gases in breathing mixtures. Carbon dioxide is a gas that's not often spoken about. It is always present. It's a narcotic gas, it's denser than air, and it has anaesthetic properties. CO2 in the arterial blood is linked to the rate of breathing, but when you get to higher pressures of nitrogen, the links can be disrupted. There are very complex physiological reactions in the lungs between the oxygen transfer in and the CO2 transfer out. CO2 is known to exacerbate the effects of nitrogen narcosis. It exacerbates the toxic effects of oxygen, and it's also, according to the US Navy Diving Manual, it also increases the risk of decompression illness. Now, I can remember people in this room talking about decompression illness in jobs in the past. The late John Bellman used to be a great advocate of the philosophy that carbon dioxide was a factor in increasing decompression illness. In my PhD work, I looked at the problem, could find no evidence for it, but the US Navy Diving Manual does actually link decompression illness to high levels of CO2. The symptoms become apparent round about 3.5 bar in air. The symptoms of excess carbon dioxide exposure. And you really want to, if you're in a chamber or an airlock, you want to maintain the carbon dioxide levels round about the same level as they would be in this room at the moment. Carbon dioxide arises from 2 sources, from the inspired gas and also internally as the waste products from human metabolism. We all generate our own carbon dioxide. The more you work at breathing, the more you produce carbon dioxide. And the more that reduces the tidal volume, the volume of the lungs breathe in and breathe out. Hence, the more carbon dioxide you're producing, the less carbon dioxide you're flushing out of your lungs. Also, you've reduced lung function due to high oxygen partial pressures. That also can lead to carbon dioxide retention. So carbon dioxide is actually quite important in ensuring the health of the worker. If you have a chamber, then people are not wearing masks. They exhale into the chamber atmosphere. You either have to flush the carbon dioxide out by ventilation, or you scrub it out using a chemical scrubber. Just want to talk a little bit about work of breathing. Nitrogen is a heavy, dense gas. As you increase the partial pressure, the mass density of nitrogen increases directly with pressure. Double the pressure, you double the weight of nitrogen you're breathing in and out. Hence, the lungs have to work much harder to inhale and exhale that greater weight of gas with each breath. And the work of breathing leads to fatigue. And because you're tired, you don't breathe as deeply, therefore again, you're not flushing your lungs as much as you should do, and that leads to carbon dioxide buildup. Just to give you an indication, density of density of oxygen is around 1.3 grams per litre, nitrogen is about 1.16, helium is only 0.17 grams per litre. So it's much less dense than nitrogen. At 3.5 bar pressure, the density of air is around about 5.5 grams per litre. Whereas if you're using a 2080 heliox mix rather than an oxygen-nitrogen mix, you'd only be breathing a gas weighing 1.8 grams per litre. So there's a big difference in the weight. And research has shown that the work of breathing, when the weight of gas you're breathing exceeds about 6 grams per litre, then the body is spending so much effort moving gas, it cannot tolerate additional carbon dioxide being generated from exercise, and you end up with high concentrations of carbon dioxide, which can lead to physical and medical problems. So again, 3.5 is an appropriate pressure to move to mixed gas in terms of work of breathing. If you're working in saturation, then a maximum partial pressure of 2 bar is probably all that people can tolerate long term. Just finally, looking at sort of decompression, onto other bits and pieces. Decompression for a non-saturation exposure, I've taken the longest exposure at the highest pressure in the Blackpool tables, and the decompression from exposure of 4.25 hours at 3.5 bar gauge takes 355 minutes from the Blackpool tables, and that's the top graph. And I say there are companies who exist who will quite happily say that they can decompress from 6 bar and 7 bar, and they can. But they can't counter the work of breathing, and they can't counter the nitrogen narcosis at these pressures. The bottom graph is a saturation decompression. Again, it's from 3.5 bar storage pressure, and that takes just over 2.5 days. And you can see there that the top graphs are very much more aggressive decompression than the bottom graph, and they're both from the same pressure. Decompression from saturation is done as a long, slow, linear pressure change, typically round about 0.1, 0.15 bar per hour. And some tables suspend the pressure change overnight. There's a 6-hour window overnight when there's no change in pressure. Depending on the gas you're breathing, whether it's helium or nitrogen or a mixture of both, you're ideally trying to eliminate them without forming any bubbles whatsoever. Stage decompression from non-sat exposures, you reduce the pressure quite rapidly, you form bubbles, you flush them out. You drop the pressure, you form bubbles, you flush them out. In saturation decompression, the intention is not to form bubbles, so you never have to flush them out. They merely diffuse away in the background. Excess oxygen is never a problem because you metabolize that out. Any bubble of oxygen in your system, you'll metabolize through normal metabolic processes. Those of you who are familiar with compressed air work will know, like the Blackpool tables, you've got 5, 6, 7, 8 pages of tables for pressure up to 3.5 bar. That table is a saturation decompression table for 18 bar and downwards. Because it's a long linear decompression, it's a very, very simple decompression table. As I said, no decompression but normally between midnight and 6 in the morning. The other thing that most of the decompression tables require is that before you start a decompression, you have a period of storage pressure. You don't have an excursion. If you're doing an excursion, you must come back, and then you must have a period, it depends on which tables you're looking at, 6, 8, 10, 12 hours back in storage before you start the decompression to stabilise the blood and the gas in the blood. Again, this table is taken from the Norwegian standard. Just looking very briefly at decompression illness, non-saturation air exposures result in about the worst combination of pressure and time probably gives you around about 2.5% of exposures resulting in decompression illness. Because the saturation decompression is relatively benign, then your level of decompression illness is very much lower. It's very rare during decompression for during saturation decompression to have a problem with decompression illness. I've talked about breathing mixtures. What do I actually mean by breathing mixtures? The one that's established itself as being more popular in tunnelling is trimix. The one that is used in diving is heliox. Trimix is oxygen, helium, nitrogen mixture. It reduces your narcotic risk, it reduces the work of breathing, and it's relatively cheap compared to heliox because you've got nitrogen as well as helium in the mix. Helium removes the narcotic risk and reduces the work of breathing and fatigue associated with it to a much greater extent. But if you have a team of 4 compressed air workers at 6 bar in heliox, they are probably breathing out somewhere between $3,000 and £3,000 per hour in helium. And if you're working day in, day out for 6 months at £3,000 per hour for helium, that's a lot of money you're breathing out. Hence the reason for helium reclaim. So trimix is cheaper because there's less helium in it. For non-saturation exposures, you require a high oxygen mix because you start off at atmospheric pressure, you need the 0.2 bar partial pressure of oxygen. And you can go up to 6 bar non-saturation. And a single mix, a 20, 30, 50 oxygen, helium, nitrogen mix can be used over that entire pressure range. The 20% of oxygen gives you a partial pressure of 0.2 bar at atmospheric pressure. It gives you a partial pressure of 1.4 bar at 6 bar pressure. The nitrogen is on the limit again, and the helium is just an inert diluent. Instead of using a 20, 30, 50, a 20, 40, 40 has been used in the UK on 1 or 2 occasions, and that's a slightly more benign gas. You have more helium, less work of breathing, or you can use a heliox 2080 as an alternative. Going to saturation mixes. They have to be low oxygen because of the high pressures you use them at. So you have to keep the partial pressure of oxygen down. So these saturation mixes are not respirable at atmospheric pressure. There's not enough oxygen in them. If you're storing at 6 bar pressure, a typical trimix might be a 6% oxygen, 65% helium, and 29% nitrogen mix. And that will give you the partial pressure of oxygen of 0.4 bar and keeping the partial pressure of nitrogen round about 2 bar for long-term use. When you go to work, again it's 6 bar, you would increase the oxygen concentration slightly, so a 10, 61, 29 mix would give you that higher oxygen partial pressure, but still keep your nitrogen partial pressure at 2 bar. Or you could use a 1090 heliox and pay the extra. Another consideration between heliox and trimix is that trimix is actually quite easy to mix. You start off in the decompression, you start off in the living habitat, and the habitat's filled with air. So you already have a partial pressure of oxygen of 0.2 and a partial pressure of nitrogen of 0.8. If you compress an air slightly, you can boost the partial pressure of oxygen to 0.4. That doubles the partial pressure of nitrogen to just under the 2 bar that would be a reasonable long-term limit. And you can then compress in helium to give you your final pressure. So you're making use of the air that's already in the chamber, using some air to give you some cheap compression, and then saving in helium costs. So there are reasons why helium trimix is a good choice. A bespoke mix is possible for every situation, really. I was involved in the work in Hong Kong. We had pressure range from 3.5 to 6 bar, and we had 20 different mixes to cover that pressure range. So to whatever pressure they were at, there was a mix to suit that situation. The other thing is quality control. It's extremely important to check the gas on receipt from the supplier, to check it before you start to use it, to check it before it goes down the hose to the person breathing it. So you have continuous analysis to make sure that the right partial pressure of oxygen and other gases is fed down to the person doing the work. Finally, fire. Fire, as we all know, is a major issue in hyperbaric work. Increased massive oxygen in compressed air increases the fire risk. So for this reason, the oxygen concentration should always be kept below 23% by volume. And that becomes a problem in decompression from saturation around about 1.5 bar downwards, when to try and keep the partial pressure of oxygen high for physiological reasons, you don't want to keep it too high because of fire safety reasons. However, just to sort of point out, once you go below 6% oxygen in the mix, you have total inflammability. Nothing will burn. So once you're working at pressures around about 6, 7, 8 bar, the environment in the chamber is totally inflammable. However, you have to come back down, back to reality, to the flammable atmosphere and lower pressures. But there is a situation where the people in the chamber have total inflammability. So finally, I hope I've tried to explain to you that saturation is not specific to diving and it's not something to be afraid of. I asked before how many people had experienced saturation. I ask again, how many people now believe they've experienced saturation? At least I've achieved something. Thank you. I hope also I have explained some of the difference between high pressure work in compressed air and diving. The differences are purely in terms of hyperbarics. There are other practical issues which we don't go into, but in hyperbaric terms, there are big differences, the excursion versus intervention, between high pressure work in compressed air and diving. So from now on, we don't talk about diving and tunnelling, we talk about compressed air work and tunnelling. And I hope also I've explained why 3.5 bar is an appropriate pressure change to mixed gas. Don't believe what people who work in China and practice in Europe say about doing 5 bar, 6 bar, 7 bar in air, because you cannot get away from the problems of CO2 retention, worker breathing and narcosis. And I hope you now have a bit of an understanding of the complexity of mixed gas work and the different gases involved. So thank you.
Well done on that.
Sure.
2 quick questions. One linked to oxygen toxicity and UPTD. When you were explaining the limits, you looked at the limits gathered during the exposure time, and you were looking at exposures on air at higher pressures and the values that they were generating. What you didn't put into that as well was that the decompression also has to be added to that, so that you would in fact lower your limit by having to decompress, usually using oxygen as well, which I think is quite an important part within that concept of it. So that although the exposure value is high, you can't give the full exposure value in that working exposure. You've got to allow for the decompression. Mm-hmm. And the last bit, right at the end there, you looked at the saturation exposures and establishing a partial pressure of oxygen, and then maintaining the balance of that with helium. All helium mixes are minimum of 2% now, so you have to allow for that addition into it as well. Up to, I think, to about 1990, you could use pure hot helium for that, but the balance now is with 2%.
The diving helium is 98.2.
Yep.
Tunneling helium might be different to diving helium. No, but I didn't want to go into, the time was a bit limited. I didn't want to go into explain that if you top up helium, you will get extra oxygen, but then if you don't use metabolic makeup, you will eventually breathe that extra oxygen back down to a pressure, to partial pressure that you can use.
Yeah, the reason I brought it up was just because we were very aware of the oxygen value within that.
Yeah.
And when I started doing it, we would establish the pressure using air, to get the correct partial pressure and then correct it with 100% helium. But as I said, from about 1990...
If you're at a partial pressure of 0.4, there's no reason why with a little bit of extra oxygen you can up to 0.45, as long as you keep it below 0.5. Because US Navy manual recommends 0.45 as your oxygen partial pressure anyway.
There's different values, but we definitely shy away from doing that.
Yeah, there are lots. One thing about hyperbaric work, there are very few things that are absolute. Zero oxygen and you're dead is absolute. Pretty much everything else, there are experts who will say this figure, that figure, or in between. So all the limits are depending which expert you're having to consult, or which set of reference documents you're going with.
Okay, I think we have time for another question. Thank you.
Hayden Davis, I'm retired now, but just going back to a job I did in 1970, which I think the situation could happen again. We were tunnelling in shale in Manchester, and it was a relatively shortish drive from the shaft, so there wasn't a driven ventilation system. And then the miners started to complain that they were getting very, very tired. So in those days, I think we were using Drager tubes, which is not very technical these days, but I think the CO2, there was a concentration of CO2 which was driving the percentage of oxygen down. So we were recommended, I think, I can't remember, but somebody from the fire brigade brought in pure oxygen cylinders. But it was all very non-technical, really. And we were giving the miners the cylinder and the face mask, and they were just taking a breath of pure oxygen and then jumping back up, doing a bit of work, and then digging at the face, and then they'd hand it to the labourer so he could take a whiff and do the digging, put the muck in the skip. So what would happen in today's more educated time for a similar situation?
I think HSE call it prohibition notice. Or you want the one-word answer, it's prosecution. You obviously need ventilation to keep the CO2 levels down. You're talking about atmospheric free air work.
Yes, free air work.
Yeah, so you're at high levels of carbon dioxide. The recommended limit is 1,000 parts per million. The EH40 value is 5,000, but above 1,000 parts per million, people start to get a little bit drowsy, lose concentration, and so on. It's not a major problem, but people in the back row fall asleep if not, the electricity isn't properly ventilated. Breathing pure oxygen is dangerous because your clothes get saturated with oxygen if you have a mask anywhere around about here. Any source of ignition, and you can set yourself on fire. You don't want to be breathing pure oxygen, you want to ventilate.
Yeah, well, that's why I brought it up, because it sounded like it was, in hindsight, an extremely dangerous thing to do. They were told not to smoke, I remember that. And the guy demonstrating it actually did take a lungful of pure oxygen and then put a lit cigarette to his mouth and blew it out like a torch, which was pretty amazing.
The other thing is that the carbon dioxide does not displace oxygen. The carbon dioxide displaces air. It doesn't displace oxygen preferentially.
Okay. The symptoms were like being, 2,000 metres up, so high altitude. You just got tired.
Because it displaces air, the concentration of carbon dioxide is much higher than you think. You measure the difference in oxygen concentration. I think that's how much carbon dioxide that you have. You've actually got 5 times that amount, because the nitrogen's gone as well. So you must measure carbon dioxide directly, and if the problem, ventilate. Don't give the guys an oxygen cylinder to breathe from.
So ventilate it when you're tunneling in shale. Thanks.
But I think also, Aidan, that shows the good old days were not that good in a lot of ways. I previously worked in the coal industry, and when I first went into a number of soft ground tunnels, I was aghast at the lack of ventilation. And on front, some of the, even back into the 60s, you hear stories about long tunnels. And if the guys wanted to smoke, they'd hop into a 40 cubic foot skip that had just come in, because the air in that was good enough to allow them to light a cigarette and smoke. But these days, the standard of monitoring, nobody goes into a heading without a gas monitor. and you know that would have just been going hell for leather. And ventilation is the standard thing.
Okay. I think we have time for one more question.
Dr. Andrew Colvin, Contract Medical Advisor. First of all, Donald, I wanted to thank you for a very clear summary that any hyperbaric physician would have been pleased to provide. My question is that you've outlined these techniques. Trimix was ready to be used in a London project last year by us. Saturation techniques are coming. Clearly these are much more complex techniques. How do you see the relationship of clients, tunnel contractors and specialists and indeed HSE developing in order to, one, get the right technique for the right project and ensure the necessary planning is completed?
As Roy says, HSE has sort of stepped back in terms of approving decompression tables, and I think the general financial situation will mean that HSE will step back more and more in the foreseeable future. I think also that there will be, as we have now, one or two companies that specialise in the hyperbaric work in tunnelling, and they will expand their repertoire to cover mixed gas and saturation. And they will expand their repertoire both in the UK and abroad to gain further experience, and we'll end up just a similar situation we have at the moment, where there are one or two specialist companies who will be able to boast extensive saturation and mixed gas experience as well as air experience. So I think that it might be that, I don't know, your former employer, Herm Connect, whether like Herm Connect might decide that there was a market for having a small specialist team within their activity, but I would have thought it's more likely to be left to the likes of the companies that do the work at the moment. One or two here tonight.
And it's also, as we recognise, Andy, that there are a number of projects have been done overseas, often with the involvement of diving companies to provide that mixed gas expertise and to integrate them into the tunnelling team. And it's a point Donald mentioned several times, the difference between diving and compressed air tunnelling, and that in the guidance there are several comments about the need to integrate anyone or anybody coming in from outside into the tunnelling safety regime. So there's scope for doing that. It's been done elsewhere, and I'm sure we'll progress in the UK in just the same way.
A habitat is a habitat, whether a diving habitat on the surface or a tunnelling habitat. You run things in exactly the same way, because the risks and hazards are all to do with the hyperbarics of it. If we think back to Jubilee Line Extension, then there was an influx of people with a diving background to be lock attendants in Jubilee Line, and since then the standard of lock attending in the UK has changed orders of magnitude. And the same thing again, there will be people offshore who are being gradually replaced by green energy, fewer oil field projects. ROVs will take over as well. So there'll be people who want to come onshore who have their own experience from offshore. But they need, as Roy says, they need the familiarisation of the tunnel environment before they can be productive.
Yes, and I do think that presentations like this to a non-medical audience, although some present might be thinking this is very technical, because there are projects overseas that are still using air at 4, 5 and 6 bar, and there are so-called specialists that are claiming it to be safe.
I have to confess, I was asked not so very long ago by a doctor in South America. They were working at over 6 bar, and I was asked, what should they do? And I said, well, obviously you go to mixed gas. And the reply was, we just physically can't, because the machine's so far in, there's no way we can retrofit and so on. I think, well, you have to be very aware of oxygen toxicity and nitrotoxicosis, the work of breathing, and you're the doctor. You have to be very much in control, do the Doppler monitoring, and just have to make the best of what you can in the situation. But it wasn't the situation that you wanted them to be in.
I think that's a good example there, Donald, of what we said earlier about this pre-planning, about foreseeing what is likely to be needed for the construction, to make sure that even if you aren't implementing it, you're making provision for it.
That's one of the big messages of the ITA Compressed Air Working Group Report 20. The client must be aware of what they might have to do and pre-plan, because retrofit is not an option.
But again, even just the simple things that many airlocks already have sufficient spare penetrations with this sort of retrofit in mind.
Okay. I wanted to take this opportunity just to thank you both for coming here this evening and being the first guinea pigs, first back. And I, for one, definitely know a little bit more about how I would answer the question of what I know about saturation. So thank you. So would like to say, and this is something, again, haven't really been able to do, is if we could all give our speakers another round of applause this evening. Thank you for that. We do have a couple of announcements this evening, so I'm hoping it's seamlessly transitioning into tonight's slides. So if I could have the next slide. So first one is, as many of you will have seen, we normally would meet downstairs in the bar. However, we have a new temporary home for this evening, so I'm hoping that many of you will join us downstairs at the Westminster Arms, which is just round the corner, and there's a map on here for those of you that don't know where it is. And if we could keep clicking, I've got a couple more bits. So as many of you know, in the past we did quite a lot of campaigning for sausage and chips. Unfortunately, downstairs is not open. However, we have secured, and there are 45 plates of sausage and chips waiting for you as you go in. And it has kindly been sponsored tonight by Specialist Plant. So thank you very much to them for doing so. So, in this same vein, we've got a couple more things coming up. So, on Thursday, 28th of October, there is a joint BTS YM and CPT YM evening seminar. But for those of you that are quite savvy, you will notice that this is delivered in Portuguese, and it is on the Silvertown Road Tunnel. So, there's been a lot of work that we've been doing at linking up with a number of other of the tunnelling societies all around the world over the last year, the amazing wonders of technology and how easy it is to be able to communicate. So if you do speak or understand Portuguese, please check it out. I think it'd be a great event. Next one. There is also another joint event. This one, I believe, is in English. This is on the Lisbon Metro, the Metropolitano de Lisboa, the green and yellow line extension, and that's on Friday the 29th of October. So next slide. The next one is to say that the BTS YM Committee 2021 and 22 applications are open, and you need to apply by the 31st of October 2021, and the application link is available on the BTS YM social media pages. So the next thing, it's got a busy couple of weeks coming up. On Thursday the 4th of November, there is the BTS YM AGM and evening lecture, and that's on explaining quality engineering. And then, hopefully you will join us back here on the 18th of November, where we are looking at digital twins for condition assessment of Brunel's rail tunnels and future applications. And then, once again, we have got the Thames Tideway Tunnel update 2021 on Thursday the 9th of December. And again, these events are in person. So what we would ask, though, is obviously with being back now, hopefully there's a couple more people that would love to come and share their stories or papers and lectures with us. So please do contact us if you have a project or something of interest to the industry. It doesn't have to be a project that you want to share with us. We're interested in all types of ideas, so please get in contact with Sarah. The next one that hopefully many of you will have spotted in our programme, we have the next BTS Health and Safety course, and this is on Monday the 22nd and Tuesday the 23rd of November here at 1 Great George Street. And for the full list of contents and to book your place, please visit the BTS website, and there's a whole page on the Underground Health and Safety course, so look forward to seeing many of you there. Right, and then a little bit of a pre-warning. Friday, the 3rd of December this year is National Tunnelling Day. So again, please keep an eye out on BTSYM's social media accounts as they'll be managing this for us. And if you've got any ideas of how you want to celebrate this with us, please get in touch. Again, open to any ideas. Next one up, it's coming around quite quickly. The Harding Prize 2022 call for papers is open. This can be on any original paper on any tunnelling subject relating to tunnelling, and please submit by the 11th of February. And it is open to any individuals aged 33 or under. Next slide. So as a reminder, many of you that have been joining us online over the last year, we introduced to you as part of the BTS's 50th anniversary year, we organised and arranged a series of tunnelling songs that are bespoke to our tunnelling industry. So please check them out. Nancy Kerr, she's a well-known folk singer who created these songs with us, particularly taking inspiration from the BTS 50th anniversary book. Please take a listen. I know from comments and things I've had, they've actually helped inspire and remind many memories of people that have worked in this industry. So please check them out, and hopefully in the future we might even get to sort of play them in here. So I just briefly mentioned the book. Many of you have heard me talking about this and either beforehand. Pre-ordering is to open very, very soon, and for those of you that were at the BTS conference, you may have seen some of the size of what this book is looking like. We've had a large number of stories to share and a large number of moments to really mark the occasion of. So you don't need to register a notification when pre-ordering commences if you are an author or a BTS member, as you will already get the information that comes through. So please look out for this. And if you haven't already shared a story with us, please also still get in touch. And that's it from me tonight. So hopefully look forward to seeing many of you at the Westminster Arms, and also look forward to seeing you next time. Thank you and good night.